I want to perform a quick DAC, and I'm going to use my Olympus EPOCH 1000i 2 1/4 1/2-inch transducer and a 45-degree wedge. Then I have this piece of carbon steel. It is about 1.5 inches thick. It has some 40,000 side drilled holes in it. At 200 thousandths, 400 thousandths, 600, 800 thousandths, 1 inch, 1.2 inch. So I'm going to make a DAC 1, 2, 3, 4, 5, a 6-point DAC from 0.2 inches to 1.2 inches. And I'm going to do the quick DAC. So what we do, of course, we calibrate our machine, and then in our options, we go to screen 4 of 5, sizing options. Press the sizing options. Down here it says DAC for distance amplitude correction, DAC or TVG, time varied gain. Press that. I'm going to press ASME, and then I'm going to hit the return key. And I'm going to couple this transducer, put some coupling on this thing. And what I'm going to do, I'm going to use peak memory. And right there is our first hole, our 0.2 hole. Let me take the gate. Well, I can leave the gate where it is. What I want to do, I want to do peak memory. So I press the peak memory. Sorry, let me turn the DAC off. Let me turn it back on. ASME. Return key. So I have in peak memory. So what I'm going to do is I'm going to go over each of these holes. That's the 0.2 inch hole, deep hole. Here comes the 0.4 inch deep hole. I'll go back and forth over them a couple times. Here comes the 0.6 inch deep hole. Now the 0.8 inch deep hole. One inch. .2 inch. Now I'm going to take my gate, move it over this 0.2 inch hole, and I'm going to press add. It'll add the peak in that peak memory. Move my gate over to the 0.4 inch deep hole, add. Move the gate over to the 0.6 inch deep hole, add. 0.8 inch deep, add. 1 inch deep, add. And 1.2 inch deep, add. Then press P4, which is done. And that's my DAC curve. So as I hit, let me turn off the peak memory. So now it's a 0.2 inch hole. 0.4 should come up near that DAC line. 0.6. There it is. 0.8. 1 and 1.2. Now I can also press TVG, time varied gain. It'll straighten that line out. And there's my 1.2 inch hole. There's a 1 inch hole. You'll see electronically it will move all these signals up to that level that we set with the DAC. The electronics will compensate for the gain according to the sound path. See that? Now let's go back to our DAC view, and you see that curve. and the curve looks kind of funny. Well, one thing to remember is near field. In the near field calculation for this probe, the half-inch probe, half-inch diameter, 5 megahertz, near field is your diameter squared times the frequency of your transducer divided by 4 times the velocity. We're using a half-inch diameter transducer. We're squaring that. 2.25 megahertz is 2.25 times 10 to the 6 hertz, or cycles, and then 4 times 0.128 inches per microsecond, or 0.128 inches times 10 to the minus 6 seconds. That's the velocity of shear velocity in mild steel. So when we do the math, you see some of the inches cancel out, keeping 1 inch up here. Seconds cancel out, and the 10 to the 6 cancels out. Bottom line is, the near field on this probe is 1.4 inches, 1.1 inches, meaning the sound path, we're in the near field until the sound path exceeds 1.1 inch. And let's look at the sound path. The sound path is the thickness or the depth of our holes divided by the cosine of the angle. In our case, the angle is a 45 degree. So that 0.2 deep hole, this guy, and 0.6 are all in the near field. 0.8, the sound path is 1.13. We're just now getting into the far field. So the rest of these holes are in the far field. So let's look at this for a minute. 0.2, see that curve? This is in the near field. This is in the near field. Not completely reliable. Let me put some coupling on here, because when we squeeze it out, it shows just how the effect that your touch has on this. So near field, 0.2 deep, 0.4 deep, near field, 0.6 deep. We're still in the near field right here, but then at the 0.8 we start getting in the far field, and you can see how it attenuates and kind of curves down. And right now it shows the coupling, how the pressure of the transducer and how I squeeze the coupling out. It has an impact on the amplitude of our signal. But that is just a quick overview of the quick DAC that we can set with this. With distance amplitude correction and time varied gain.